And we're back. Welcome back. You are on to new topic of today, two-way tables. Two-way tables is a way to organize data and then use that data to calculate probabilities that we're interested in. A lot of people use this to just organize their data in a fashion that lets them read the data clearly. So the first thing we're going to do is we're going to talk about how to actually make the two-way table. So this says a survey was conducted on 113 students. There are 55 students who play instruments and 40 who play sports. Let's highlight some key information. So on 113 students, 55 students play instruments, 40 play sports. Of the students who play an instrument, 39 do not play sports too. So let's highlight that again. So the students who do play an instrument, they don't play a sport. So the first thing is this 113 is our total number of students. So it goes in the bottom right cell. This is our total. Then we know that there are 55 students who do play instruments. So this is an instrument total, so play instruments, 55. 40 students play sports in total. So that goes right here. And now based off of this, we can actually use our calculator or our mental math and to see, well, how many then don't play a sport? How are we going to get that number? We're going to subtract 113 minus 40. That gets us 73. We can also get this number here as well because you either play an instrument or you don't if you're taking the survey. So we're going to subtract 113 minus 55 and we'll get 58. Okay. So then let's take into account this last piece in light blue. Of the students who play an instrument, so of these 55 students, 39 do not play sports. So that goes in here. This helps us because then we can figure out this number because we know that there are 55 students who play an instrument and 39 don't play sports. So how many are left over who do play sports? So 55 minus 39, we get 16. We can do the same type of math work to figure out these two numbers. There are 40 people who play sports in total. 16 also play an instrument. So how many are left to not play an instrument? 24. Notice these two numbers should add up to this. These two numbers should add up to this. These two numbers should add up to this. And so we can do the same math work to find this. I'm going to give you a minute to find the starred, that empty box, and then I'll put it in. So you can sort of confirm you should get 34. Okay, so now that we have a full and complete two-way table, we're going to answer some questions. What is remember this reads out loud as probability that the student plays an instrument. So here we want to go to the total number of students who play an instrument. That's 55. Out of, remember it's desired over total. This is our total population, 113. Done. Let me just clean this up a little bit. Okay, what is the probability we chose a student who does not play sports? So we're looking in the does not play sports category, and the total here is 73. That's our total desired out of total number of students surveyed, 113. And we're done. What is the probability that we have chosen a student who does not play an instrument? And, this is gonna get good. And does play sports. Let's use a different color for this. And that keyword and means we're looking for an intersection. So let's look. Okay, plays an instrument. Who does not play an instrument? Here. These are all the students who do not play an instrument and does play sports. So let's highlight does play sports here. Where do those two lines intersect? In this cell right here. So these 24 students are the students we are talking about. They are our desired. So they're in our numerator, and we're still out of a total population of 113 students. I'm going to let that sink in just a little bit. Oop. There we go. Because this next question is slightly different. What is the probability that we choose a student who plays an instrument, so yes, instrument, or, this is a new keyword, or plays sports? So what we're going to do is, since it's saying or, we don't care if they play an instrument or they play sports. We don't care if they only do one or if they do both. We want to count all of the students who either play an instrument or play a sport or do both. So let's look in our table. So plays an instrument, that's here and here, or plays sports, that's here and here. So notice we have 3 boxes that matches. We're only using the inside boxes. So what we're going to do is, we're going to add up all those students who fit our category. And what's our total population? Still the 113 students who took the survey. So now we're just going to add up the numbers 16 plus 39 plus 24, and we're going to get 79 over 113 as our probability that we choose a student who plays an instrument or they play sports. Notice we only count this 16 once because it's the same 16 students who are doing both. Now let's look at this last question in this context. What is the probability that the person does not play sports or does play sports? Why does this number make sense? So let's go back to our two-way table. There is a way to do this without using the two-way table, but we'll talk about that in just a second. Does not play sports. Here are all the students who do not play sports. Here and here. And does play sports. These students play sports, these students play sports. So when we add up these 4 numbers, we should get 16 plus 39 plus 24 plus 34 divided by, what's our total population? 113 still. We actually, when we add these all up in your calculator, we get 113 over 113, which is equal to 1, which is saying 100%. So why does it make sense that the probability of either not playing sports or playing sports is 100%? Because you have 2 options when taking this survey. Play sports or don't play sports. You have to pick one. So every single person checked off one of these 2 boxes, which takes us back to all of the people who were surveyed. I think we'll do one more example. If you're feeling ready to give this a go on the Desmos activity, go ahead. I do have one more example, so you can always come back to it. You can pause the video, try a couple of problems, then come back to this video. So last year, and we would have done this year if we were in class together, my geometry class took a survey about their food and musician preferences, and it looked a little bit like this. Of the following musicians, which one's your favorite? Choose one, Adele or Beyonce. Of the following food items, which one is your favorite? Choose one, fruit, mac and cheese, hot Cheetos, or pizza. And so here is some of the data. It's part of the data, not all of the data. 59 students took the survey. 22 students said they liked Adele more. 23 students said fruit was their favorite. 8 students said mac and cheese was their favorite. Start to color coding. Only 6 students said they liked hot Cheetos. And 22 students said pizza was their favorite. So let's start by just filling in those numbers. So 59 students took the survey. Just a reminder that the last column and the last row are used for totals. So 59 students taking the survey, that is our total box. 59. 22 said they liked Adele more. So in the Adele total box, we'll have the number 22. Now remember that 59 total students took the survey, so how many are left to like Beyonce? We will subtract 59 minus 2 and we'll get 37 students in total liked Beyonce. 23 students said fruit was their favorite, so fruit gets a total of 23. 8 students said mac and cheese. 6 students said hot Cheetos. And 22 students said pizza was the bomb. So now we need some more information so that we can fill in the middle piece. 16 students said they liked fruit and they liked Beyonce. So we want to look in the table. Here's where we have fruit. Here's where we have Beyonce. Where is this box where they would have both? So fruit goes across here, Beyonce goes down here. So this is going to be 16. This helps us because then we can say, oh, well, a total of 23 people liked fruit and 16 said they liked Beyonce. So how many were left to like Adele? We're going to subtract again, 23 minus 16, and we'll get 7. The next sentence says 2 students said they liked Adele and hot Cheetos. So Adele, hot Cheetos, the box, 2. And again, 6 people in total said that they liked hot Cheetos. If 2 said they liked Adele, how many must have liked Beyonce? 4. 7 students said they liked mac and cheese and Beyonce. Okay, mac and cheese and Beyonce, that was a 7. Great. There were 8 students in total who liked mac and cheese. Only 1 student said that they liked Adele and mac and cheese. And then very last one, 10 students said pizza and Beyonce. They said those were their favorites. So 10 student, Beyonce, pizza, 10. How many are left over if there were 22 people who liked pizza? 12 to like Adele. So it takes a little bit of time to fill out the two-way table, but once we have it filled out, it's super helpful because now we can answer some questions in a very organized fashion instead of having to read through all of the information. So what is the probability of picking a student who likes Beyonce? So probability of Beyonce. Remember, always go back to probability is desired over total. Our total number of students is 59. How many students liked Beyonce in total? That's that 37. What is the probability of picking someone who likes fruit? 59 students still in total. The fruit total is 23. What is the probability of picking a student who likes Adele and pizza? Now there's that keyword and again. So we need to look at where Adele is. Here's Adele. Here's pizza. Where do they intersect? Where do they overlap? the 12 right here. So 12 over 59, that would be the students who like both. Now what about, change it up a little bit, Adele and Hot Cheetos. So again, we have Adele, but now we have Hot Cheetos. Where do they intersect? 2 out of 59 students in total. I'm gonna go ahead and erase this. Okay, what about Beyonce or fruit? And remember, for or, it only needs to fit one of the 2 categories. So where are all Beyonce people? They're all right here. And all the fruit people are right here. And so we want to include all of them. So we're going to go ahead and add up 7, that's this 7, plus 16, plus 4, plus 10, plus 7. Out of a total of 59 students who took the survey, add the numbers in our numerator, and we will get 44 out of 59. What is the probability of picking a student? We'll go ahead and erase the highlighter. Who likes mac and cheese or pizza? So again, with or, it just needs to fit one category to meet our requirement. So let's highlight where mac and cheese here, or pizza, the row below it. So these students who are highlighted in purple are the people we're interested in. So probability of mac and cheese or pizza equals, and again, we want to count all of them, so we'll add them up. 1 plus 7 plus 12 plus 10. And we'll divide by our total number of students. 8 plus 22, 30 out of 59 students. And now here's our last question for the video. What is the probability of picking a student who likes Adele or Beyonce? So here, I'd like to, instead of going and adding things up, let's think about the question. Remember, they had to pick either Adele or Beyonce. So it is guaranteed. We know for a fact that a student that we choose out of this sample will either like Adele or Beyonce. And if something is guaranteed, what type of probability number would you think we would see? 100%. You have to have either chosen Adele or Beyonce, so there's an 100% chance that the student you pick will like one of the 2. Please feel free to come back to this video, pause it. The document will be posted on Google Classroom as well for you to try some of these problems again on your own if you want to, if you're having any trouble with the Desmos activity. Also, if you have any questions, please come for office hours. Please come for class time. I look forward to talking to you, and I hope you have a great rest of your day.